with glass covering. I do want to keep building roof glass visible. It helps me to understand what are building structure points. And then the rest of the glasses that I keep visible are the ones that we classify into using machine learning. So there's 10 vegetation, 13 building structure, 15 tree, 17 car, 18 pole, and 27 structure, 28 machinery. And I start looking for any mistakes. Here I see a couple of cars which have ended in the vegetation glass. I'm going to use tools in this toolbox for doing classification. And sometimes I'm going to use tools in this toolbox for modifying the grouping. So you need to be able to use both the manual classification tools and the manual grouping or group painting tools to get things done. But for these cars, I use assigned point glass, and I have classified set to gold group. And I classified to glass car. And then one click on the car is enough to classify. Here I see something where it looks like it's a truck. Perhaps traveling in the same direction with the helicopter. So it is quite a long truck. It's not in one class. That tells me that it's not one group. So it is wrongly classified. It is classified as building roof and building structure classes, but it is really a truck. And I need to decide if I want to put it into car class or if I want to put it into machinery class. And maybe I go with machinery. It is quite different from a typical car. That my cars are mostly personal cars or vans. And this here is that is more than 20 meters in length. I'm going to make this into one group, so I use grade point group and say that I will grade using inside fence, and then I draw a polygon around it. And then I can use assigned point class and classify into machinery. And I go in here, and there's something that is classified as building roof. I don't think these are buildings, I think these are containers or something that we attach to a truck. So I'm going to classify these into a structure. And this stuff here is not vegetation, that's clearly structure. And this one is structure. Here we have a car. It was one group, two cars. So here I want to create a new group. I create a new group from one of the cars, and then I have two groups both classified as car. This one is probably a car, but for one reason or another, we don't have a very nice pattern of points on it. If I decide I can do something like this, that I create a group which would take in these points as well, and then perhaps classify it as a car. when I look in a place like this, I see quite a lot of objects that I want to put into structure class. Many of the circular ones are trampolines. So that is an example of what kind of objects end up going into the structure class. And so now I keep looking at different places and anything that I see that catches my eye as being incorrectly classified, I try to classify that. Here we have another bolt that goes into structure that looks like that's man-made, and this looks like it's man-made. And this is clearly, it's probably a trampoline case. Yes, it's a trampoline and that goes into structure. I do have some buildings which have not become building because there's not so many hits on the building roof, that the building roof is non-reflective material, and then it has not become building roof, and then there can be many different classes. In this case, I would classify all the points inside fence into building roof. Here I have another place where there's a building which is only sparse hits. I do want to classify this as building roof rather than have it in different classes which are used in the machine learning. These points have been grouped. And when I classify all of these into building roof, then it might be a good idea to clear by class, to clear the group value of all the points in the building roof class. And then I know that if I classify a whole group with assigned point class to, for example, building structure, that only the points, those points get classified and not something that I already classified as building roof. So the building roof points may have been in the same class with an object close to it. Maybe the most common type of classification that I do is classifying from vegetation into structure class. And here I have a third case where a building doesn't have enough hits on the roof. It has not become building roof classified. Inside things into building roof class. are some place where I have classified something as a power line tower. There are some points classified as wall. It's a small number. So the laser scanner doesn't see walls much, but there's a little bit of walls somewhere. But we need to select the classes that we want to use machine learning to classify. So it is 10, 13, 15, 17, 18, 27, 28. And the software shows how many groups we have in each class. By the way, if there is a group which has more than one class, training model ignores that group. So the groups should be one class only for training model.
What about building roof?
Yeah, so you may have building roof points which have a group number, and you just selected 10, 13, 15, 17, 18, 27, 28. So the classes which we try to classify with machine learning. So and at this point, you have done your own manual editing. You don't have the same point cloud now that I have. So your result is going to be a little different from what my result is going to be. So the number of examples that we have in vegetation is 3,486. In machinery, we have only 28. And it may be a good idea that we don't use every vegetation group to train the model. And we don't use every tree group to train the model. That those would dominate perhaps too much the solution. So we do have a limit here. That I'm saying that from one class, the software should use a maximum of 500 groups. And then the ratio of vegetation groups and machinery is not as big as it would be if we don't impose any limit. Randomly would mean that when I go to this tool, again, I will get a different set of groups. And for our work, it is easier if we get a more systematic selection of groups. We are still going to be editing the classification. And if random bit is off, then we get mostly the same groups if we start the tool again. And if we spend some time to improve the classification, we want to get the same groups again, so that every time we start, we get as clean training data as possible. And in the model field, we select decision forest. Decision forest is really random forest. So that's the more common name for the algorithm. But someone has a trademark on random forest, so I don't want to have it as a word in the software. So I use an alternative word in decision forest. The algorithm itself is published and it's not patented, so it's free for anyone to use, but someone has a trademark on the term random forest. So, but decision forest is the same as random forest. And I have a setting on that I want to use 25% of the groups for validation, which means that the software selects the groups to use from the active point cloud, limiting to 500 per class, and then 25% of the groups in each class are reserved for validation. So we use 75% of the groups to train a model, and then the software can test how the model will classify the validation groups. And if the model classifies the validation groups to the same class as we provide, then we get a high success rate. So we get a report which tells us how good is the model when we apply the model to the validation groups. Do we get the same result class or something different? And I have exclude groups at block edges. So I'm always going to have some groups which are at the edge of the block. And I don't necessarily have a complete image of the object. And it's not a good training example if we have half a car. I want to have a complete car. So exclude groups at block edges means that the software gives out any groups which are very close to the block edges. And now you can click OK. So now the software has selected some of the groups and brought those into training model. Maximum of 500 per class. So there's going to be 500 vegetation groups and 500 tree groups because I had more than 500 in those classes. And then building structure, car, pole structure, machinery. The software has picked every group from the active point cloud, which is not at the border. And right now we just see a list of classes. We need to add some parameters to see what the rest of the lists, what the rest of the items in the dialog are going to display. So we should add a parameter. I want you to go to parameter pull down menu and add. And type is symbol. And in category, we choose geometric. There's 4 different categories. If you don't have the latest software, then you just have 3 categories. Shape has been added in the release that I did on Monday. But first we add something from geometric category. And this here is relatively simple, or at least simple to explain statistics about the group. So length would be how long is the group. We are going to first add maximum distance. Our distance values are height from ground. The biggest distance value is then how high above the ground the group reaches. For a tree, it would be height of the tree, measured as a height from above the ground. So we have single geometric maximum distance. And then you can select the maximum distance in the top list. So the top list is a list of parameters. And whatever we have selected in the top list, the rest of the items, they display values or information about the maximum distance values that we get for the groups. So I can see that vegetation class, the smallest maximum distance is 0.321. The biggest maximum distance is 20.76. For building structure, the smallest is 0.318, and the biggest one is 27.34. And this graph shows how the values are distributed. So it's something of a histogram display of the values. And from that one, I can quickly see if the parameter is giving me separation between the classes. So if we look at the car class and the pole class, every pole has a bigger value than any of the cars. So this parameter alone gives me perfect separation between cars and poles. The lowest list is a list of groups. It shows a class, such as building structure, and it shows the value for maximum distance, because maximum distance is here, maximum distance for that group. And this list is always sorted. Biggest value is last, smallest value is first. And at this point, I do want to make use of the parameter values to find outliers. I have explained that the difference between vegetation and trees is the height from ground. Trees are 4 meters or taller, and vegetation is less than 4 meters in height. And a tree looks good, the smallest value is 4.006. But vegetation, we have something which is 20.76 meters high. And I can see in the graph that for vegetation there's like 2 outliers. And I will always, when I add a parameter, I'll look for outliers. So I might be interested to look at this one machinery group, which has a much bigger value than any of the other. I might be interested in looking at this structure, which has a much higher value than any of the other structure groups. But vegetation I now want to pay attention to. I'm going to deselect all the other classes in this list so that it's only vegetation, which is now displayed in the 2 items under need. And now this list of groups shows vegetation only, and it is sorted, so I know that the biggest value is the last one. I'll first zoom into a nice zoom level, then I go to the end of the list, and I click on the last one. And I can use show location to highlight some of the points which belong to the group. And I can see that it looks like a tree to me. So this here should be classified as tree, not classified as vegetation. So I'm going to use assign point class. I'll classify the whole group to tree class, and then I identify one of the points. I have changed the classification of this group. I'm going to remove it from the training model system for now. Now the biggest value is 6.618, and it is quite a special case. It is fallen trees. So it's not a normal tree, it's not even a normal vegetation case. It is something very special. And I may decide that I'm going to classify this out. I would be happy having it as vegetation. I would be somewhat happy having it as a tree, but I don't think it's a good training example. It's such a special case. So I'm going to classify this into high vegetation class. High vegetation is outside the machine learning, so it's not going to be used as a training example. And for the training data, I may make a decision that something is a special case. I classify it out. And I will remove this vegetation group. In structure, I have also a very high value, 18.93. And it's this one. So I might also consider that I classify it into something else. It's not a typical structure, it's a very, very different case. I don't have a really a suitable class. So it's not a power line tower, it's not a telecom pole, it's not the same kind of pole as the rest of the poles in my data set. So I don't really have a nice class for it. I might create a class for a tower and classify it into that one. Or I can leave it in a structure if I believe that if there's something like this, I want to have it classified as structure. But now when the editing of vegetation groups, two groups have been edited, I now have a situation where maximum distance gives me perfect separation between vegetation and tree, and that's to be expected as I have that rule that 4 meters is the limit. Smaller than 4 meters is vegetation, bigger than 4 meters is tree. And the maximum distance also gives me a perfect separation between cars and poles. So maximum distance is a great parameter to use.
Заметил, Денис, у Арта в машине или какой-то объект на огромной высоте.
So on
На
the
крыше.
member there is a presentation folder, and there is scan new features, and that one has a list of the parameters, and there is a short explanation of the parameters. You don't need to understand every parameter, but you should understand some of those. The ones which are easiest to use, easiest to understand, and have the biggest potential of being good parameters. The geometric ones are fairly easy. So area is the 2D area of the group. There's 3 distance parameters. We use maximum distance, there's also minimum, and there's average. And so they all use distance values, which normally should be height from ground. So maximum distance is the biggest height from ground value in the group. Minimum distance is the smallest height from ground value in the group. And average distance is the average height from ground value in the group. Average jet ratio is a value that tells us if we have a tree, is it a case where majority of the points are close to the top of the tree, or is it a case where a lot of the points are close to the base of the tree? So it's a value describing between minimum and maximum, where is the average elevation. If there's more points at the top, then the average elevation is closer to the maximum than minimum. If majority of the points are at the lower half of the elevation range, then the average jet is closer to the minimum than the maximum. So it describes the shape of the group in terms of elevation and distribution of the points. Circularity is how close the shape of the group is to a circle. One way of computing it there, not the only way of computing circularity. Crown sharpness defines how sharp is the top of the group. Edge complexity is how simple is the outer edge of the group. Is it a shape like a rectangle, an even-sided rectangle, or something quite different? Edge ratio is how many of the points are on the edge, and that describes how thick the feature is. So is it a wide structure that many points are interior points, or is it a case where almost all the points are on the edge of the group? And in that case, it must be something that is thin. Height is the maximum elevation minus minimum elevation. Length is the length of the group based on a 2D line fitted through the points. And width is computed using the same principle that the software fits a 2D line through the points. And the width is how much the point spread is in the left-right direction. Rectangularity is how close the 2D area of the group is to the area of a rotated bounding box. And volume is the volume of the group using voxel-based computation. And we have radiometric parameters. These come from color, or intensity, or amplitude, or reflectance. The most common one of these to use is the vegetation index, which I already explained that on this data set, vegetation index is not so good in separating vegetation and non-vegetation from each other, that the vegetation is not so free. Then we have computational parameters. This is not up to date. I have added 3 computational parameters since this list was updated. And these are somewhat more complex to explain. So I'm going to explain a few of these. Okay, so I have actually now edge complexity and edge ratio are listed here as well. We'll check where it is in the software. Edge complexity and edge ratio are in the geometry and are not in this, do not belong under this category. But I will explain a few of these, the ones which are useful, most useful. Transparent ratio is the relative number of non-last echo points. And what this is all about is, if we have a tree, we have a lot of cases where the laser pulse hits a upper branch. Part of the laser pulse continues further down, gives us a second return, and part of the laser pulse travels further and perhaps gives us a point from the ground. So in a tree, we have a bigger percentage of points which are not the last echo, that the surface is not a solid surface that returns the whole laser pulse. So one can think that it is somewhat transparent. If we have a building roof, then majority of the laser pulses, when they hit the building roof, the pulse doesn't continue further. The whole pulse comes back from the same distance. So transparent ratio I will often use to be able to separate trees and more solid objects from each other. Transparent ratio doesn't work so well if it's short vegetation. If we have a shrub which rises to half a meter above the ground, in that case, all of our points are typically last returns. So the laser system has a minimum separation. It doesn't give us 2 points if the return signal comes from a distance with only half a meter difference. For that reason, there's another similar ratio called solid ratio, this one. It counts what is the percentage of the points in the group which are last echo, meaning that it is solid based on the echo information, but that the point is above a given minimum height from ground. So if we have a last echo, which is 20 centimeters from the ground, it doesn't tell us that it's a solid object. The laser pulse may have traveled further down, reached the ground, but the system is not capable of giving us 2 points. It only gives us 1 point. So the solid ratio is like the opposite of transparent ratio, but it's not computed the exact same way. It takes the height from ground into account. And it's useful because it's not the exact opposite, that it is computed in a different way. If it was the exact opposite, then it wouldn't give us any additional value. But solid ratio and transparent ratio are 2 parameters that I will often use to help distinguish vegetation from non-vegetation. Grain roughness gives us a measure of how clean the surface is. And I would expect that on a building roof, it's a small value, and in vegetation, it's a bigger value. Surface roughness is almost the same, but then it can be a curved surface. It's a second degree surface. Close by 2D ratio we need for building structure. So building structure is something which is next to building roof, either completely above a building roof or right next to a building roof. Close by 2D ratio computes how many of the points have a point in a given class, such as building roof, within a given search radius in 2D. So next we are going to use parameter add, and we add a radiometric parameter. And we use the vegetation index, and we choose visible band difference. So we are now going to add some of the most commonly used parameters so that you get an understanding of what those means. And the most commonly used parameters, when you understand those, then it helps you to find outliers or badly classified groups. And now you click OK. And we look at vegetation index. And now the graph doesn't look so nice. That the groups over different classes, they overlap a lot. So the vegetation index has less value than a maximum distance for classification. If vegetation is green, then vegetation and tree classes should have big values, and everything else should have small values as a general pattern. Now, there is a lot of vegetation which has relatively high values, and there's a lot of tree groups which have relatively high values, but I also see some small values, especially in vegetation. The vegetation index calculation is such that if it's green, it should be positive. So now the negative values in the vegetation and tree classes are something that I may want to check. Are those really vegetation, or is it something else? Is there a badly classified group? So now I'm going to select deselect so that I only look at vegetation and tree, and I have things sorted. And the smallest value in there is minus 0.08. And your situation may be different. Everyone has done their own manual classification. And this here is a tractor, it's not vegetation. So I'm going to classify this into machinery. And I'm going to remove it from the list. And then I'll look at 4. And I don't think it's vegetation. That it must be man-made object. So this here is the yard of a company that rents construction equipment. I don't think there's going to be vegetation on the parking lot, but there may be some boxes. So I do think that the correct classification is that it should be structure, and this one as well. So I'm going to remove this from the list, and then I'll look at the group which has now the smallest vegetation index value. This one I have no idea what it is. And I have to decide if I read it as vegetation or if I classify it as structure. It doesn't look like vegetation, but that if it's structure, I have no idea what it is. Maybe I will leave this one in there. And I look at the next one, that looks like it's vegetation. The next one, this here, I would think that it is more likely structure. So based on the location, structure is more likely class. This one, not vegetation. I would say that this one is more like things. So I'm going to classify this one into things class, and I'll remove it from the list. This one looks like vegetation. This one looks like it's maybe a stone, a rock. But I don't have a class for rocks. Maybe I put it into structure. So, and this one looks more like vegetation. So now I have classified some of the smallest values in the vegetation and tree. So the parameter has helped me improve the classification to some degree. So I have done some changes to the classification. I'm going to save the points. Next, we will add something computational. So you go to parameter add, and we take from the computational category, and we are going to use transparent ratio. And you will select transparent ratio from the list of parameters, and then switch all the classes on. And first we take a look at, does transparent ratio, does it separate any groups from each other? And we can see that all the cars, in my case, have a smaller value than any of the trees and any of the poles. So definitely there's some value in the transparent ratio. I would expect that trees have bigger values. So majority of the trees have bigger values, but then there's some which have a slightly smaller values. And maybe I want to check those. Vegetation can have small values. So I already explained that when the vegetation is short, then it doesn't show up as non-blast returns. That when everything is close to the ground, then everything is a last return. But now I do want to look at the tree class only, and I want to look at the smallest values in there. My smallest value is a case looking like this. And I don't think it's a tree, it's a pole and a fence. So I'm going to classify using fence, classify it from tree class into fence class. All the points inside fence looking like this. These points still belong to the same group. So I'm going to go to group and clear by class and say that I want everything which is fence to have 0 as the group. And next I can use assign point class and classify this group as pole. And then I can remove this group from the trained model system. The second smallest one, it's a similar case. That it looks like it's a pole and then some vegetation. I'll now go in and I'll create a separate group from these points which look like they are a pole, and I will classify that into pole class, and the rest of the group goes into vegetation. It's not tall enough to be a tree. And I will remove that group from the trained model system. which doesn't have so much transparency. It's something of a special case. We have a vertical leaf, and then the point in here gets a high value in height from ground. It's not really a significant tree. It is more like vegetation than a tree. But the height from ground is the rule by which we separate trees and vegetation from each other. So I don't think I'm going to make any change to this one. Then I check the next one. And this is a case where, again, it's a building roof, but non-reflective roof surface. It hasn't become building roof. And it really should be building roof. So I'm going to classify here this as building roof. And then what I see here, that can go into building structure. And I will remove this hook. And this is again the tree of the vertical leaf. And then the next one, it's a real tree. It's a spruce, which is very dense, and we don't have so many non-last returns. So I think I have now done as much work as I can do using the transparent ratio to improve tree classification. So I ended up with one tree which has 0.253. And I could equally well decide that I classify this into high vegetation, as it's not a typical tree case. So maybe I go in and I classify this one as high vegetation. I will be happy with that as being the class. And this here is the same kind of a case. I did classify something as building roof, which was good. And I would really like to have building roofs without a good value. It's easier to do things when I have that separation. So I'm going to use hook here by class and class 6. Maybe we'll also put in solid ratio. So you go to parameter and add, and single, computational, and solid ratio, and it can be 0.8. And you set the solid ratio, and first set all the classes on. So I would expect that something like cars are more solid. Structure is such a big variety that structure can be anything. But there is one car which is like an outlier. I want to check that one. And it's not a car. So this one should be vegetation. So I'm going to classify to vegetation. And I remove it from the training model. And now all the cars have higher values. And trees and vegetation, I would expect those to have smaller values. So I may want to check what do the ones with the biggest value they look like. Are they really vegetation? And they do look like vegetation. The biggest tree one is 0.866, and it also looks like it is a tree. The one which is 0.857 in my case, that's not properly classified. That my grouping has not managed to put everything into the same group, and part of the machinery has ended up in the vegetation. So here I am going to create this into one group, and I'm going to classify that as machinery, and I will remove the vegetation group from the list. Then I have in vegetation something here with 0.844. This one looks like it's structure, not vegetation. This one looks like vegetation, this one looks like vegetation, this one looks like vegetation. This one looks like vegetation. This one it's hard to say what it is. This one is not vegetation, this one I would classify as structure. So again, I have used a parameter to help me improve the classification of the point cloud. We will add one more parameter which results us editing many groups, and that is the close by ratio. So now I want you to go to parameter and add, and type is single, category computational, and close by to the ratio. Radius can be 1 and class can be building group. And this one we need for building structure. So this one looks to see if there's how many of the points have a building group point within 1 meter in 2D. And my definition of building structure is that building structure has building group close by. So I should have non-zero values for every building structure. I select that in the list of parameters, and I can see that some of the building structures do have 0. So I'm going to hide all the other classes, and I will look at building structure class. And anything which is 0 or close to 0, I want to check. I believe this here must be structure. It's not close enough to a building group to be building structure. So I'm going to classify it to structure and remove it from the list. This one, I have a hard time understanding what it really is, but it doesn't belong in the building structure. It's not touching any building. I'd rather have this here as structure and then remove it. This one also should be structure. This one should be structure. This one should be structure, not building structure. It's not next to a building. This one looks like it's vegetation. Here I have a case where I have two cooks, and only one cook is now close enough to the building roof. But I do believe that this here belongs to the building. So what I'm going to do here is that I merge point hooks. I identify a point on the bigger hook and then a point on the smaller hook, and now they have become one hook. And then I can classify, or now I don't have to change classification, but they were both in the building structure class. I can just remove it from the list. And this one looks more like a fence. So I am going to put this here in the fence and then remove it. And this here looks like it's probably vegetation. This one, the same story. Vegetation is the glass I want to put it into. This one I already removed. This one should be structure. So not vegetation, but structure. Here is the same kind of a case that there's two hooks. I merge the hooks. And then that should be okay. This one now has a non-zero value, but I do want the limit perhaps to be a little higher, so I'm going to classify this as structure and remove it. This one looks like vegetation. This one I use the same merge principle. This here can go into structure. This year I rank this one as vegetation. This one may be the same. This one I put as fence. This one the same, that it's more a fence than as some other structure. This one looks like it's a structure. This one I will put into structure. And now I start to have something where I may decide that, okay, I've now done enough, that these have a big enough value from the close by to the ratio computation. So 0.167 is the first value that we accept as a building structure. Next, we will add one type of a parameter that we haven't used so far. So you can go to parameter add. we will add something called ratio. So that is one parameter value divided by another parameter value. We want the category of both to be geometric, and we want the first one to be width, and the second one to be a maximum distance. So then this is the width of the hook divided by height from ground, highest height from ground in the hook. And you click OK. And you select that one. And all the poles have small values. So poles are thin, so the width is small, but poles are relatively tall, so the height from ground is relatively big. And then for poles, the ratio is small. This is not really as useful as one can think, as we have other parameters that also separate poles quite nicely. But let's add that one so that you see at least one ratio. The ratio, I'm not sure if I will keep that in. I may remove it. So I'm not seeing much of a value of the ratio. So if we add both width and maximum distance as parameters, and then maybe we get the same value in the model. You should save the points. And I have been doing quite a lot of editing on the glasses and sometimes on the hooks. And I have removed that hook from the training model system. And what we are going to do next is we select rebuild hooks. So this one recollects the hooks. And then I have the full set of 500 for those classes where there is more than 500 hooks. And all the hook information that training model uses is updated. And we have a number of parameters selected. We can now run training. So you go to File and Run Training. And there's a couple of settings here, but right now we ignore the settings. We do know that this is not going to be our final model. And I will try to explain the settings later on when we run this run training again. And now you click OK. And you get a report which tells us what is the success rate of the model that we have just built in classifying the validation hooks. So for vegetation, the report tells us that the software used 375 hooks to train the model, and it used 125 to validate the model. And the model that we have classifies 124 of the hooks as vegetation, giving us a 99.2% success rate based on the validation hooks. On building structure, we have a 100% success rate. On trees, we have a 100% success rate. On cars, we have a 93.3% success rate. Or when we say we, I mean me. Your result is different. Everyone has a different classification how done. And goal is 100%. Structure is only 52.8%. And machinery is only 42.9%. So those are not so good. But overall success rate 94.9 starts to be a very promising overall success rate. We aim to improve it, so we continue our work to improve the success rate, and we want to see how far we get. Now that we have a model built, we can go to New Display, View Folder Menu, and select misclassified groups. And what that means is that the list at the bottom is going to show us those groups where the model gives a different result. The list is going to show both training groups and validation groups. So the classification was done on all the groups, but only the validation groups were used in the success rate computation. And you have no way of seeing which groups are used to train the model and which groups are used as validation groups. And so that is on purpose, so that you can't cheat. You don't know which ones are validation and which ones are training. You can still cheat in other ways, but you can't cheat by knowing which ones are training groups and which ones are validation. But now we select misclassified groups, and now this list shows those groups where the model is a different classification result than what I have given as my training data. And now we can probably find some classification flaws by going through this list. And what the list is saying is that I have something which is classified as structure. The model would classify it as vegetation. And the model is 100% confident that it is vegetation. When I look at that, it doesn't look like vegetation to me. I give it a structure. I look at the next one, a similar case that I have classified it as structure, and the system believes that it's vegetation. On this one, I have a hard time deciding if it's structure or vegetation. PowerPoint Cloud doesn't help me. Maybe I will go with what the model tells me, and I will classify this as vegetation. Here I have classified it as structure. The system believes that it's vegetation. I don't believe that there's going to be vegetation in this place, so I leave it as structure. This one I have classified the structure and vegetation, and the system believes that it's structure, and I will go with the structure. Here I have classified as structure, system thinks it's vegetation, I think structure is right. Here I think I am right. Here I believe I am right, it is machinery. Here I believe I'm right. Here I believe I'm right. So only the ones which I see that I have a misclassification that I will change. This one, is it structure or is it vegetation? I don't know, maybe I'll change it to vegetation then. If the system believes that it is vegetation. And now I have taken a look at all of those groups where the trained model gives a different result from what I have done. And I think I classified 4 groups differently from what my original classification was. So now I'm going to save the points. And in the train model, I say rebuild groups. And then I use the run training again. So I'm interested to see if my success rate improves. But now let's pay attention to the settings that we have. So there is a store class and there is a store confidence and there's a use all project logs. So I already explained that in a real project you would want to send multiple logs to use as training data. And you need to have a project which has those training blocks in it. So 1 block here, 1 block there, 1 here, 1 there. And you open 1 block at a time and you go to the training model. And the block that you have active, you can modify. You can make changes to the classification. But when you use run training, you can say that you want the software then to collect examples from all of the other blocks in the project as well. So that we have more data to train the model. The limit of 500 groups would apply per block. So that if we use 4 blocks, then with 500 as a limit, we can have 2,000 training examples, out of which 25% would be kept for validation. we don't have additional blocks, so this one can be off. We can store the classification that the training model gives us. I have a class attribute machine class. You probably don't have that. Let's go and add. So now you go to scan settings and extra attributes. And some of you are going to have extra attributes training. So these ones in there. But what you do, regardless of what you have in the list, is that you click add and you give name machine class and category class. And the data type is forced to be unsigned Python. So we tell the software that we may want to use an attribute called machine class for storing classification. And you click OK. Perhaps you save. And then we go to run training in the training model. And now you can select machine class as the place to store the machine learning classification, and reliability as the place to store confidence. And click OK. Now my report tells me a success rate of 96.2. So things are looking a little better. Machinery is not looking so good. That is only 42.9% success rate. We don't have so many machinery examples, and the machinery is going to suffer a little bit from the fact that there's so many more examples in the other classes. But I don't know if it's a good idea to limit the number of examples from 500 to be smaller, so that the number of examples would be more even. There's not going to be so many machinery groups in the complete data set. So if we train a model to very easily classify something as machinery, it's probably going to do bad classification in many cases. So I don't really know what's the best strategy in that regard. But things are improving. 96.2 is better than what I had before. And now we have two classes on the points. We have the classification that I have done, and we have the classification that the trained model would give. And we can do things like this. You go to View, Display Mode, and we color by class difference. Color, or we use class, and as the secondary, we use machine class. And we switch everything off except machinery. And the class difference coloring works so that if the two classes are the same, then it displays the points using intensity-based grayscale. If the two classes are different, then we get the class color from whatever is the first class selected here. And then also visibility. Visibility always comes from class. So we can also do it so that it's machine class and apply. And then I would see that, okay, the trained model, it classifies those four as a structure. And then I have the ability to look at these and perhaps understand how these are different from the rest. Is there something in the shape of these that results in that? Or is there perhaps something in the coloring of these that results in that? But we can look at the points colored by glass, and in the glass coloring we can choose if it's the glass or if it's the machine glass. So now we are displaying everything that is machinery in my classification, but we are displaying using the color that comes from machine classification. And we also have reliability. So now I want you to color by reliability. And pick colors. And limits something like this. Red 35, orange 50, yellow 60. So anything which has a reliability smaller than 35 is going to be colored in red. Anything which is between 35 and 50 is orange. Anything between 50 and 60 is yellow. And now we can see the groups where the machine learning model is not so highly confident. So the ones displayed in red, displayed in gray, the machine learning system is quite confident that it is machinery. But the ones displayed in color, the trained model doesn't give us a high confidence rating, that the confidence rating is smaller. And if I need to do manual editing, then one can use the reliability as an aid so that you can concentrate on those groups where the reliability is the smallest. So now we have looked at how you can make some use of the storing the classification and the reliability that the trained model gives us. And now I'll go back to glass coloring, and I'll switch to the original display: building roof, vegetation, building structure, tree, car, pole, machinery, structure, glasses. And next we're going to run something called add best. So this one, the software selects the parameters that it finds to give the best success rate. So you start at best, and there's two modes. One is start from scratch. So the software will select all the parameters. The second mode is keep current parameters. So the software will keep the parameters that you have selected, and it will only add additional ones if that improves the overall success rate. And the benefit of AddBest is that you don't have to understand the meaning of the different parameters. I would expect that not very many of you know what is the meaning of average only variance. And you don't need to know. So it is enough that you will understand some of the parameters, the most common ones, like the ones that we selected, to help you improve the classification of the point cloud. And the final creation of the model, I would recommend that you always use AddBest. Either keeping the current parameters, the parameters that you have already had, or you go with start from scratch. And let's do start from scratch. And click OK. And this is going to take some time. So I have been adding, the last updates, I have been adding parameters. And then that has made this process slower and slower. In the next update, I will probably have speeding done for this operation that it can run faster. But now it's something like 4 minutes on my computer, so I think that it may be 10 minutes on some of your computers. So we'll take a break now. They take 15 minutes and then we'll continue. So in 15 minutes, all the computers should be done.
Тепло ли к тебе, Денис? Он на тебя дует.